Hello, everyone. Welcome to Jaxon. Jaxon is an AI platform that uses large language models and brings them into formal methods where we can prove the output of the model is sound. For use cases like the Freedom of Information Act, you really want to trust the output, and that's what Jaxon brings to the equation. Okay, so there's the so-called hallucination problem within large language models where they're making things up. You give it a prompt, it can give you a multitude of answers, and you don't know which one is right. It can be completely fabricated, it can be contextually off. Number of issues with trusting the output of large language models. We do a lot of work with the Department of Defense where they require formal methods, formal proof that the output is sound, yet still leveraging the power of generative AI, the power of all the large language models that have come into play. All right, so there are a number of techniques to address this hallucination problem. A lot of people are using this retrieval augmented generation technique, which basically means you're creating a knowledge base that you trust and you can pull representative data into. We think that's an important part of the process. It just doesn't get you all the way to formal proof. So we recommend it, we use it, but we're going beyond that and doing this step around symbolic reasoning, which I am going to talk about in a moment here. So our technology is called DSAIL, Domain-Specific AI Language. It is taking the output from large language models and turning it into these domain-specific languages. Domain-specific languages that have been designed with subject matter experts. It is codifying basically the grammar of typical speak in that domain, and it's understanding that the output of the large language model that's in natural language needs to be converted into this structured language so that we can then impart constraints, assertions, rules, insert certain facts from this knowledge graph, and then mathematically solve the problem. So it comes down to math. This is going to hurt for a second, but think back to grade school math where you had a formal proof that you had to go through. You were given a problem, you had to show the logic, and at the end, you had one answer and only one answer. That's what these solvers are doing. And then we have this verified output where we can have a human finally do the final mile of fact checking to make sure that it is accurate and just hit yes. Or if it comes back as no, then you need to know you have to go through the loop again. Okay, knowledge graphs power a lot of our understanding. The world is a graph, as our chief scientist likes to say, and everything has a relationship or it doesn't have a relationship. If you look at the right side here, these don't have a relationship with each other, but the way that all the data is organized, you can figure out the links between each one of these, what are called nodes of the knowledge graph. And we're balancing the knowledge graphs with the large language models so we can get the best of both worlds. Building this knowledge graph takes some time. You do need to understand the schema. You do need to understand the ontology that you're working off of. But fortunately, AI can help with this process, and the techniques and tooling that we've created at Jaxon also expedites this process. Once the knowledge graph is built, then you can lean on it for application-specific use cases. Like we did here for Project Battering Ram with the Air Force, where we are automating the classification process. So we're looking at security classification guides, which are PDF files that we can parse and then put some smarts around so that we can understand exactly what they are trying to convey. So when it comes to Freedom of Information Act, we can look at a security classification guide. Here's an unclassed version where we are given some guidance as to who can see what, at what classification level, and then using machines to dictate what needs to come out on the other side. Not dictate, I meant to say it is making determinations as to this new piece of information coming in, this new request for information, and what the guidance has been from these guides so that we can make these determinations. Again, leaning on the knowledge graph and the large language models to help automate this whole process. Going to skip through here for interest of time, but learn more at Jaxon AI. I will be available for Q&A now. Thank you.